Hey guys, Mike Noel here, Blockchain Weekly. What a week it has been in the blockchain space. So many things happening. It's incredible to count. I will kind of give you guys an update. On Monday of this week, I did an event for the Southwest Security Professionals Group, which is some pen testers, some sysadmins that are interested in blockchain. I was asked to present at the event a month ago, and I sat down, and a month ago I jotted down some things that I needed to talk about, and I put together some slides. What happened was when I went to grab my slides and start my presentation, work on my presentation on Monday morning, I realized it had only been a couple of weeks, and most of the stuff that I was talking about had already become old hat and really not that interesting. It's really, there's some things happening with Ethereum. There's some things happening. If you guys don't know Whisper, if you haven't looked at Whisper, then you probably should. If you haven't looked at Swarm, then you probably should. Swarm is the Ethereum version of DNS, where there's hosting. Whisper is the distributed ledger kind of messaging that goes on. Really interesting stuff. Blockchain continues to bang it out of the ballpark. Miners. If you're a miner, if you can see, let's see. I've got a test mining rig going right now. I'm testing 1080s, doing some mining for Ether, and I'm just watching the GPU stuff go up and up and up. There's a couple of things that are kind of hinting at the fork for Ethereum. The last Vulcan was on a event, and I can publish that the link for you here fairly quickly. He was on an event on Monday and was wearing a Hard Fork Cafe T-shirt that said Ethereum on it. So we can automatically assume what he's working on. Lots of things happening in this world, and it's becoming mind-numbing, the changes and how quickly they come. Anyway, I want to thank you guys for coming to Blockchain Weekly. This is a weekly event where we get together and we kind of talk to someone or a couple of someones. We've got some really interesting guests today. Brian and Flip of Fluree, which is a database company, blockchain database company. They've got some interesting, interesting product, and I think you're going to enjoy this. I really do. And they'll be on in just a moment. But here at Blockchain, we try and talk about things that are looking at the internet of trust as opposed to the internet of value. What do I mean by that? We had the internet, we had the internet, we had the Internet of Things, and that's the refrigerator that talks to Amazon and gets you milk. We had the Internet of Data. That's remarketing and target marketing and that kind of stuff. We got the Internet of Value. That's like Bitcoin. Bitcoin is a way to store value and transfer it on the internet really quickly. Then we had the Internet of Trust. The Internet of Trust is what's happening now with Ethereum and smart contracts. We're actually able to take trust, put it on the internet, and transfer trust in a smart contract. It's like a if this then that argument for. Hang on just a second. I forgot I need to record this. The Internet of Value is what we're talking about today. We're talking about different things within the Internet of Value, and to further complicate matters, I am administrating this shindig for the first time and probably not going to do a very good job of it. So it's going to be a rough ride, folks. So make sure that you keep your seat in the upright position and keep your tray tables up. And I'm going to bring on, welcome to Blockchain Weekly. We're excited about having you here with Fluree. And why don't you take it away? It's been kind of a rough start for me today. Why don't you guys kind of go ahead and take over? Kind of give us some indication of who you are, why you're here. Some indications on what you're thinking about the blockchain space and what you think might be happening in the future.
So we have started a project. Actually, we started about 3 years ago to facilitate a platform that could power decentralized applications. And there's several components to this, and really the first and the one that we've now released in beta form that anyone can sign up for and utilize is the database. And it's we call it FlureeDB, so we're not too creative about it. Pretty simple name, FlureeDB, and it is a database that's built at its core on blockchain technology. Yeah, so this really aimed to do two things, FlureeDB, and besides being a foundation for sort of distributed enterprise applications, but it aimed to be a better database. So we have a very long history of working with databases, especially Flip, who hopefully we'll be able to pull on here. He's been working on database technology since the late 60s and built or been the leader of some of the biggest companies in the space. And I've been working with Flip now for about 20 years, and we have just built a lot of enterprise applications and worked with a lot of database technology in a lot of different contexts. And we thought there was an opportunity to build a better database. And of course, blockchain is something that we're very passionate about, and some of the implications that it has. Again, a little bit more focused towards enterprise software here, although its applicability is pretty broad. And we thought there'd be some opportunities to really merge the two together in some unique ways. And so in addition to creating hopefully a better database is what people end up taking away from it, we've also created a way to, we think, make blockchain technology just more accessible to developers. And some of the challenges we find with at least the current technologies is it is brand new technology. It requires developers to develop a new set of expertise to use it. It requires them to change their technology stack, which creates a whole new set of sort of management overhead that needs to happen as far as, what if the smart contract's not working? How do we troubleshoot it? How do we fix it? How do we get it back online? And the idea was that if we could actually take blockchain technology and put it at the core of a database, all application developers know how to build and work with databases. So we don't really need them to change the stack, and we don't really need them to change the way they think about building an application. Every application starts with the database. So here are the choices. Okay, I can choose Oracle or MongoDB, or I can choose FlureeDB. And of course, the thing that comes with FlureeDB is all of these better benefits, but also some of this blockchain capability. And then we also saw some of the challenges, and I think it'll hopefully change and mature over time, but with companies trying to use blockchain technology like Ethereum. Ethereum was designed really for, smart contracts, computing, but it really wasn't designed to handle anything, or not much anyway, related to data. And of course, as we address some business problems like supply chain management, a typical supply chain might generate gigabytes of data in no time. And storing gigabytes of data on the Ethereum blockchain is, it's not fair because it wasn't really designed to do that. But it would cost you, I haven't done the latest calculations based on the latest price bump, but I think at least $10 million. Where, of course, that would cost you just a few pennies to store on Amazon S3. So there wasn't really technology that enabled this foundation layer to happen, but still enable some of these blockchain characteristics and things like that to happen. It looks like we got Flip on now. Is that right?
I think so.
So, Mike, I don't know if you wanted to take this in a certain direction, but it'd be great to let Flip do a little intro.
Why don't we let Flip do a little intro and tell me if that echo comes back. I'm just muting myself anytime I want to talk, so we'll see if this works. But hey, Flip, hey, thanks for coming on board. Thanks for being here at Blockchain Weekly. And why don't you tell us a little bit about yourself and what we're doing?
My background in the database space is pretty lengthy. Part of it was honed in Motorola and IBM environments where the creation of things like DBOMP, CFMS, DL1, all of those preliminary databases that were part of the past cultivated, and I worked on all of those, and I ended up ultimately working as the chief operating officer for a company called Culinet. That was the IDMS codicil database management system. We had a great run with that business. Cullinet became the largest software company on the planet during the 1980s. Ultimately, I ended up then leaving and starting a firm called Platinum Technology, which created a variety of tools for relational database management systems, DB2 and Oracle in particular. Those environs, just to clarify, if you had to build a relational database system 20, 30 years ago, maybe even longer, you would have built it the way Oracle is today. If you had to build Oracle today, you would never make it the way it looks, and you would never create it the way it is. And that goes for MySQL and lots of other starting to be long in the tooth database environments. So after we grew Platinum to $1 billion in revenue, sold it for $4 billion in 1999, the next endeavor was in a lot of incubation spaces. Technologies that are to be created. Silk Road Technology, where Brian and I spent many, many years, was a SaaS vendor for human resource suites. It was a suite of human resource products. Became a very large, substantial software SaaS vendor. And then about 6 or 7 years ago, I in particular got very interested in blockchain and thought of it as perhaps the building blocks on which one would create a whole new breed of database. One that, if you looked at FlureeDB and compared it to Cassandra, you compared it to Mongo, you compared it to Oracle, or any of the other alternatives, you would say, hey, 99% of the time, I'm going to pick FlureeDB and avoid making a big mistake. So basically, we formed this business about 3-4 years ago and started putting together at a cost no object funded database system that would in fact appeal to everyone who wanted the most comprehensive way of dealing with data in the block. Frankly, I would say the objective was also that even if blockchain was not part of the equation, you would still pick FlureeDB over any other alternative. And if you had inclinations of wanting the immutability and other things that were part of Fluree and blockchain, you would certainly pick that alternative. That's kind of my background. I turn it over to Brian, who I think is going to cover the rest of this.
Sure.
Yeah, and Flip, I definitely I can definitely relate to the databases and building databases and how we did things 20 years ago, and the differences we have today. There's a lot of legacy types of things that really hold technology back in a lot of ways, I think. So I really appreciate your comments there. And are you guys getting the echo again when I'm talking?
No, it's good when you
Okay,
talk.
good.
I'm not.
Yeah, just when I talk. Yes.
Yeah.
You know, I've been accused of that before. Go ahead.
The thing that is very important to sort of add to the equation is the fact that all of the constraints, whether they were CPU speeds, whether they were data volumes, whether they were performance, all of the things that were constraints before, Moore's law has greatly affected since that 20, 30 years of passage of time. And now things are very viable, very possible that couldn't even be comprehended.
Yeah, I think I think we were using Molnix when we landed the Apollo spacecraft on the moon. That basically it was the data was on a wire recorder, and we've come a long way since then. And I think we've kind of skipped a generation with our databases and the software that we're using and how we write programs. And I think we're having some issues with errors. I think if you look for the bounty programs that exist for various softwares and things of this nature, I mean, everyone's grabbing bounties, and it's just because we really haven't gone through and rethought what we do as far as software is concerned. Bringing us into Fluree. So I kind of want to set a tone here. I want to give you guys prep that we're going to ask some questions about Hashgraph. We're going to ask some questions about Swarm. and compare and contrast with some of the things with Fluree. But Flip or Brian, could you? So here is a person that's in the audience here that's working on rationalizing a workflow at a small business, and they're going to be using distributed ledger to rationalize this workflow. And now we're ready to do a smart contract and start doing some different things. How is Fluree going to help out? Where does Fluree come into the process? And how do we get started? Does that make sense?
Yes, I think it makes a lot of sense. And Brian, I think will take you through that, unless he's disappeared.
I think I scared Brian.
No, he's there now.
I cut out a little bit.
Yeah, there you go.
Yeah, so I guess rationalizing the workflow of process management. So it's pretty broad. I would say if you are focused on building an application, generally you need some sort of state data for that. And generally you would turn towards a relational document database, graph database, whatever the case may be to actually store that information. So that is certainly one way that we want people to be able to kind of approach these problems in the same way they've been approaching them before. What we want to be able to do is, under the covers, give you blockchain characteristics, and in fact do so completely transparently if you don't really care about it. If you do care about it, you can get into various aspects like which parts of the database data reside in different consensus levels. Is this like a private blockchain consensus level? Is this something you're running internally, or is this a full public blockchain consensus? But the idea is that at its core, you don't even really need to worry about that from the get-go if you're just trying to get an application up and running. And the benefit you get is that while we haven't talked about some of the ways we feel like we've kind of changed how you interact with databases, you get a very modern database. So let's just put it that way. You get something that hopefully solves a lot of hard issues in dealing with databases today. But you also get at least the one core characteristic of that blockchain brings to this, which is really the tamper resistance. So the idea that all this data that you're storing is all there, it's immutable, certainly brings a level of comfort for any sort of application you're developing. You don't have to worry about kind of a traditional database. We call them update and place databases, but essentially they lose the historical context unless you're logging it out for some period of time, but lose the historical context of what was there. So you have the full history of everything that was ever there, and then it is also assembled that history into blocks, and those blocks are hashed, much like Bitcoin assembles blocks, which makes them highly tamper resistant. So we think that will definitely have an impact on things like auditing. Where do you go to figure out if data's been tampered? Well, if you have a very tamper resistant system of record at the core, you don't need to go anywhere. It's all right there. You don't need to, if you're PricewaterhouseCoopers, you don't need to ask for this documentation from this department and emails and Excel spreadsheets to try and piece together whether or not essentially process controls within an organization were followed. You can just look at the database and you can have trust in the immutability characteristics. So that's how we would like people to think, and that way they don't really need to think about learning, a new programming language called Solidity, which they've never used before, or, how am I going to connect this into my, JavaScript front-end web app, and, what does it talk to? And there's a lot of things that kind of come with that when you're changing how you're building applications. So our hope is that we can bring some of these benefits without changing how you would approach that problem to begin with.
So that's a pretty high level answer to the question, and that's in a business workflow. I think we understand that. And once again, anyone that's in the audience at any point, if you have a question that you want to ask of someone, a couple different options. You can raise a question. We have a question of Flip. And I think Eric is asking if you're an advisor to Crypto Trust. Do you know who they are, or is that something that you're involved in?
I am not.
Okay. So this is an example. Eric, you ask a question and we'll give you an answer right away. So any of you guys that have questions when we're talking about Fluree, about the database, about a specific application even, please feel free to raise your hand, and we'll give you we'll ask that question for you, or alternatively, we can actually bring you up on the stage and you can interface with us. So I think we've had. Tell me about the application in Fluree where you think it is most likely to be used, and what are some of the things that we want to see when we're looking at specs and we're looking at implementing a Fluree database. Does that make sense?
Yeah, makes sense. I think it's a little bit easier for me to ask where it's not a good fit, because it is designed to be a pretty general purpose database. It is a graph database, although the way you interact with it, you don't necessarily have to know all this. If anyone's used a graph database, they all seem to have this kind of very different way of querying them than like SQL, which everyone's used to. And we very much adapt a very familiar SQL syntax. We don't require you to learn about vertices and edges and all this sort of graph theory stuff to be able to utilize the technology. But what was your question again, Mike? Oh, mute. Oh, you're muted, but I recalled anyway as you were talking. So the areas where it would not be a good fit is certainly incredibly high volume transactional data. So, what we're looking at in the order, in sort of the magnitude of transactional speed here is somewhere around 1,000 transactions per second within a database itself. And at least for most business applications, or really most applications in general, probably 90+% of them, that fits within the needs of how often data is updating. But if you have something like incredibly high volume that you're trying to push through it, not only is blockchain as a concept maybe not the right solution, but certainly our database isn't optimized towards that. It's actually optimized towards doing very rich, even programmatic permission models inside, and there's a lot of extra work that we do over even what a MySQL might do to figure out if data can be updated, where it's coming from, dealing with things like consensus. So that naturally sort of prohibits super high volume transactional data. There are concepts that are not blockchain-y, which can potentially apply here, like IOTA's tangles, for example. That is a way of doing high volume sort of distributed ledger technology without a blockchain. And that has some implications here, but it also has some challenges as it relates to database. So really our core focus is blockchain, and therefore we kind of have this upper threshold. Really any sort of web application is perfect made for this. Because of our graph query interface, you can just follow relational data kind of all the way through the graph and actually get back in JSON. So it's real easy to work with. Get back responses to your queries in real time, but in that graph form, which is usually exactly how applications need it. And we've done some other things for kind of web-based applications that we think make it even more valuable. One thing we've done is we've actually built a query engine in JavaScript that synchronizes to the blockchain transactors, but you can actually run it in process, like right inside your iPhone app or your Android app or your web app. And your app will issue queries to the local database, and that local database will automatically know what data it already has. It'll go fetch in batch data it doesn't, and it'll actually automatically handle real-time streaming updates. So it'll be able to create real-time applications. So that's an example of where it's like a perfect fit, and sort of on the other side where it's not a good fit is probably things where you need to do in a single database, more than 1,000 transactions per second. And
where we all are familiar, and I'm sorry if the echo has come back again for some reason. We're having some technical difficulties there, but we have a couple of things going on. Number one, we have a question I want to get to, but I want to talk just a little bit about transaction and velocity, and link that into a question we're going to have in the after this question is Hashgraph and how that works. But what is it? The Bitcoin ledger is at about 7.5 transactions a second now. And we're looking at the Ethereum that's at 3 or 4 transactions a second. It's not very scalable. And Is this something, am I kind of going down the right where we can actually have transactions that are off chain but relate back to a chain where we can have a coin where we're conducting transactions via a coin, and we are tracking those transactions on Ethereum. So we have the data stream for the distributed ledger. We understand where all the coins are. We understand which transaction was first, but we have a need for data outside of that, as opposed to using standard MySQL queries or setting up a standard database. Fluree has some definitive advantages as far as the database and the integration. I'm probably wrong, but is that anywhere near correct?
Yeah, well, I guess you're talking about Ethereum as it is today, and there's all these technologies have roadmaps, and I would say all of them probably acknowledge some of their issues and have some degree of plans to work to resolve them. So resolving the transaction speed at Ethereum, they have two strategies that they're looking to do that with. One, of course, is a migration off of proof of work to proof of stake, and they think they can get a lot of efficiencies there, and probably can. And then the other strategy is that of sharding. And so these are kind of two aspects that we address at the core, and I'll get to kind of your off-chain question in a minute. So how we actually handle this, and it's not that, we're lucky because it's a little easier to do in our context, is that databases operate sort of in isolation regardless, and so they make a natural sharding technique. So our shards, we do have sharding built in, which enables this higher transaction velocity, as you call it. And the shard is a database. And technically, the shard's actually a database partition. So if you have really high volume databases, you can actually partition a single database into many sort of smaller partitions or shards. But most people will probably just use a single database. But every single database is its own shard, and therefore really its own blockchain. So that, of course, solves, a lot of issues. And, Ethereum will obviously become faster as they implement sharding, as they're proposing to do, and not too soon off, but pretty far away. But regardless, it's something they're looking to accomplish. And then you asked the other question, sort of this off-chain method. And this off-chain method is becoming a lot more popular. You also bring up Hashgraph, and the same thing. And sort of these directed graph, you can't call them blockchains because they're not blockchains, but these, Hashgraph, IOTA is an example, obviously a pretty popular one of this. They're using a different type of technology to do high velocity transactions. And we actually see potentially a merging of those two. So using kind of a backbone consensus model, which might be proof of work. In the case of Bitcoin, we actually are big fans of proof of capacity, and basically your side chains, your side chains become, like IOTA tangles. They become, like IOTA, the whole thing runs as a tangle. But what if it didn't run as a tangle? What if sort of a side chain ran as a tangle, which could support very high velocity? But it always ended up linking back into the core blockchain, which is using something a little bit more traditional, like a proof of work sort of chain. It's the combination of these things that I think will be, at least in the near term, some of the where some of the velocity really comes from. But yeah, in proof of work and proof of capacity, and maybe even to a degree proof of proof, these are not super fast. So achieving that velocity is going to be challenging, but it also goes against why are you using a blockchain to begin with? Generally you're using it because you want this trustless consensus method. And that is, for lots of applications, a very valuable trade-off to getting speed. Some applications it's not, but you need to choose the right application for the job, and none of this stuff is going to be one size fits all.
Yeah, I agree. I've looked at literally hundreds of different applications, and definitely there's a lot of people that are trying to force the blockchain application into their world when it really doesn't belong there. I look at is there a transfer of trust? In other words, in the transaction that you're looking at, or in the workflow that you're looking at, or what you're trying to do with the blockchain, is there a transfer of trust? Are there sticky bits? Sticky bits are people and personalities, where people try and negotiate, renegotiate, change the, grind the price, or make some sort of a comment as far as the quality is concerned. And then is there money in the transaction? Because if there's not money in the transaction, it really doesn't make any real sense to move forward. And then the last one, of course, and I've added this recently, is does it make it simpler, right? Does it simplify the process? Growth hacking rule number one is make it simpler or someone else will. So that's really what we have to be looking at. So that's kind of the metric I look at it. And that my metric, and 50 cents will buy you half a cup of coffee at Denny's. But there's got to be a transfer of trust. There has to be some sort of a sticky bit that's in the process that we're looking to overcome in the transfer of trust. And we have to look at is there money in the transaction? Is there value that's enough to move forward? And does it make things simpler? Or if it doesn't hit every one of those with spades, I mean, you just don't look at blockchain traditionally to go into it. I want to get some questions up, and we've got a couple of them that have been up there for a while. And is this something like Neo4j? And I don't know what Neo4j. Do you?
Yeah, I do. Yeah. So it is probably one of the most popular kind of graph databases out there today. So it's used a lot for new applications. Say someone's building a new SaaS application. In the respect that it's a graph database, the answer is absolutely. It's a lot like it. We bring some other interesting characteristics. Of course, we've been talking a lot about blockchain. One of the things we've been able to do is, since we're storing an immutable history of that database in the form of a blockchain, how do we actually leverage that information that most databases don't have, because they sort of forget it, or it's in backup tapes that they need to restore to get access to it up to a certain period of time, whatever. How do we take that rich data and solve real problems with it? So one of the things that we have built in is the ability to do point-in-time querying. So when you issue a query, like a SQL-looking query into FlureeDB, it will respond as any other database would, with the information it currently knows about that query. It'll answer your query. Optionally,
so Fluree has the opportunity to do time travel.
Yeah, time travel in the fact that every single query that you ask, you can optionally say, I want to know the answer to this query, but I want to know it yesterday, I want to know it a year ago, I want to know it 2 years ago. In every single, you think about it like micro versioning, every micro version of the database is available at your fingertips for real-time queries, so you can go back in time. We actually allow some ways to go forward in time too. If you want to do scenario planning or things like that, you can basically create transactions that you don't physically store in the database or commit, but you pretend like they're there to then run whatever you want behind it to your app, to be able to run it in the future and see what this report looks like 6 months from now, assuming this transactional data transpires between now and the next 6 months. So yeah, we allow time travel, and it's immutable. So, it eliminates, if you're an application developer, you've all dealt with probably the least fun thing to deal with, which is race conditions, where, while your application is processing something, the database might be changing underneath it, and some error happens because, function A ends up calling function B a millisecond later, but the database changed underneath it, and now they have two different results over the same data that they thought they would get. With Fluree, when you get a database, that database never changes. So we completely eliminate race conditions in applications. And basically, every time maybe a new request comes into your web server, you just grab a new database. And the idea that you can actually be running thousands of versions of the databases and thousands of application processes simultaneously, to us, is trivial. We use, so it really changes how you think about a database. A database actually becomes like a variable, as opposed to like this thing that you need to go send a request to. And in fact, so much so, you can actually run our query engine in process right next to your application. And it really even starts to change how you code. Because normally when you're coding, you're thinking about, I got to go ask the database for this data. Well, that's really expensive. It takes a long time. So I'm going to be very, very conservative with what data I ask for and how often, as I'm trying to, process a request. When you have your database essentially right next to you, you just start coding differently because you can ask questions instantly and get instantaneous responses. So we really have changed kind of how you think of a database by this idea that we separate the query engine from the thing that's actually processing transactions. And then the other benefit and why this makes sense in the blockchain space is that only one node essentially is in control of that database at a specific point in time. So it can ensure the consistency and the atomicity of a database. So the idea is that, it's like not in reality, but it's like a single threaded process is processing transactions serially. So your database can never be out of sync. You can do things like atomic transactions with guarantees and all this sort of thing. And basically the result of those transactions create a database state change, sort of some additional logs. And those logs then get synced to all the query engines. And you can run thousands of query engines. It doesn't really matter. But the key is your applications are talking to the query engines, and they're getting responses in, most of our queries are like sub 2 millisecond response times. So they can scale arbitrarily. They're not concerned about the scalability of the blockchain aspect because we've actually split the database into two different things.
There's some ramifications for me there that are quite significant. And it's going to take me a while to process it. I'm not the sharpest knife in the drawer for sure, but it's interesting that it's a single thread, and at that point you're not having overwrites. You're not having data that's being written from one source on top of a database on another, and you don't have that issue.
No, in fact, locking. Database locking is one of the problems that plague and make things like Oracle so complicated. It needs to quickly figure out what parts of the data it needs to lock and freeze while it's trying to handle all these requests and do all this stuff. And it's enormously complex. It is completely irrelevant to FlureeDB.
Right. The transactions take so long that it's relevant who's coding and who's writing to the database. But with yours, it's not so relevant.
No,
that's interesting. That's going to be one that's going to spin around my head for a little while. And I want to get to another question. We have one more question from the same guy. In cybersecurity, resilience, AI, and machine learning, how are they related to your database and any company using your database for ICOs?
Okay. Well, a couple questions there.
Yeah.
So I would say, as it relates to artificial intelligence, the food of artificial intelligence is data, of course. And in that regard, we're a tremendous food source for artificial intelligence. And mostly because we are immutable, we have the full history of everything that happened, and time is most databases kind of have two dimensions. They got a table with rows and columns. We have three dimensions. We have time as well. And lots of AI-oriented algorithms, one of the more important aspects of it isn't the data itself, but it's the time. What's the pattern of when things happen over time? And we have all that. So a normal database doesn't typically store that type of data. You would have to go through some extra effort to retain that. And one of the things that we're finding is that people are trying to come up with some algorithms to answer questions. And they got some good idea, and then the first thing they need to do is find the food source, right? What data do we need to power this algorithm so that we can find that answer? And then the challenge usually is oh shit, we don't have that data. It's not there. We need to start tracking it. And then they start tracking it, and maybe 3 months later they have the data to feed it. If you have every piece of data that you've ever had over time, and this is pretty cheap to do, storage is so cheap, then hopefully, as you're coming up with new questions to ask and new algorithms to run, what you'll find is you already have the data you need to power them. You don't have to, wait 3 months to collect a new piece of data that you weren't already collecting. So, what we have doesn't have anything specifically to do with AI, but like I said, I think we will be a better food source for AI algorithms than a typical database would. As it relates to ICOs, it's an interesting question. We support in the database itself a programming language. So, Ethereum has Solidity. we have kind of our own programming language. It is designed, Solidity is designed to be a general purpose programming language. Our programming language is really designed to work with a graph database and execute custom predicate functions. But those functions are very, very powerful, and they can actually enable smart contract-like behavior. So we see technologies like Ethereum and Hyperledger being a great complement to FlureeDB. They're really focused more on, in a traditional application stack, the app tier, the business logic. We're more focused on the database itself. There are some areas where there's a little bit of overlap, and there are some smart contracts that you might normally go to Ethereum to write that could be fully written right within a FlureeDB. But there's other things that are going to be very custom, programming logic that are going to be better suited for Ethereum. All that is a long answer to say that you could write the logic to do something like an ERC20 offering within FlureeDB. I don't know if it would make, at this point, more sense for you to choose that over doing it in Ethereum or something else. I'll probably be able to answer that question a little bit better in the future as things play out. But that type of custom logic programming capability is actually capable of doing right within the Fluree database.
Not only that, but I think the other components of the database is just a foundation layer, would provide for the richer description of applications. Not that you can't use Java, not that you can't use Python, not that you can't use anything else right now. Fundamentally, any language that you choose can become the way that you contribute to and from FlureeDB. There's no real restriction there. Fundamentally itself, just so you know, this doesn't affect any customer, any user, anybody who's looking at it, but the product was written in Clojure, so it's a functional programming strategy underneath the covers, where certain things that you can do in a functional programming language are possible. We're using something.
That's interesting. Clojure. I don't think I think that's similar to Lisp, if I remember correctly.
Actually, it is. Yeah, it's based on Lisp. Yeah.
Based on Lisp. Okay. So and that gives me a clear path. I understand now. Going back, and you're talking about, I had some interesting questions about, is there a service that we can use as a GUI to, when we have the database and we're looking at it? You talked a little bit about the data that we have, and I wanted to ask just a quick question, and we got 5 questions we got to get to. So is there a really quick answer? Is there a company or a service that you're using as a GUI for the database?
Yeah, so we've actually built a GUI for the database that allows you to query or see what's going on or visualize the schema. We'll even paint a graph of the schema of the database and allow you to transact right from it. Obviously, an application would normally be doing it. And it's worth pointing out, we do have our own query syntax, which is very SQL-like, but it's defined in JSON. So it's really easy to compose and do things with. But we also actually support GraphQL as well, Facebook's GraphQL. And GraphQL has a pretty rich ecosystem of tools around it. And all of those tools work with FlureeDB natively. So, if you want to pick up any GraphQL tool, or you're writing a React app and you want to use GraphQL under the hoods, it can connect to a FlureeDB. It'll do its full introspection, understand the schema, and just work.
It's a great tool set, just don't ever use it. Quick question from Dan Myers. How does latency and ACID base RMDBS compare to blockchain overhead? Of course, that depends on blockchain implementation, but if possible, give a broad answer.
Yeah, so this is kind of what I talked about a little bit before, is that you should really target, well, for one, we use sharding. So that immediately scales the number of transactions we can do, and we shard at the database plus partition level. The second part of that is that we're really targeting applications in the sort of sub 1,000 transactions per second range for some of these reasons. We think that fits most applications, but there are obviously applications that need more than 1,000 transactions per second, and we wouldn't be a good fit for those.
So something like building an exchange that would have multiple transactions on multiple multiple chains and keeping some sort of a database on what's going on, big high volume, that kind of stuff, this would work well for that.
If it's very shard friendly data, we can still work very well from it. But for example, I wouldn't try to replace the New York Stock Exchange with FlureeDB. I would custom write technology to do that only solves that problem, because that's kind of what you need for that use case.
So Fluree sounds acceptable to supply chain management, particularly for time-sensitive storage and delivery.
Yeah, so I cut out in the middle of that question, but let's see, supply chain, particularly time-sensitive storage and delivery, please comment. Yeah, supply chain is just a phenomenal use case for FlureeDB. The idea that a group of companies can run a database where no one controls it. You set up the rules ahead of time, exactly which data and under what conditions that data can be transacted by whom. So you kind of have this level playing field you set up. And then you can incorporate notions like even voting in there. So if 50% of the supply chain wants to change the permissions or wants to alter some business logic for the database itself, then those transactions go through. And if, for example, they don't, then they don't go through. It keeps running by the same rules that it's currently running by. But supply chain is a great example. There's use cases probably for every industry, but that's a good one.
And we do have a couple more questions here. Give me a good example of your best, most successful use case in this part. Is it in a specific industry, or is it with a specific application that goes across industries? Or
yeah, sure. Go ahead.
Flip. Chime in, prompt you maybe to describe how time travel into the future would affect a cap table application, because that's got sort of immediate recognition by folks as to what is happening. And two, one of the things to remember is that you can write the query against any number of databases, some of them private, some of them federated in the hands of n number of authorized and permissioned users, and write that same query over the third component, which is a completely public blockchain database. And you, as the writer of the SQL, don't have to know anything about what they are, that they're private or they're federated or they're public.
Yeah.
Which is the whole idea behind decentralization, more or less. So thanks for that. I want to get to a question here. Flip, for you. I talked with Flip 20 plus years ago when I left IBM Research to launch Privacy Inc. Are there any specific privacy autonomous capabilities built into Fluree? And that comes from Ed Alburn.
Hi, Ed. Brian can add a lot more to this, but I think the immutability of it is a big part of that privacy. You can chime in.
Sure, and I guess there's a few layers of it, and I won't belabor the point because I know we're running out of time, but if you're talking about privacy from the standpoint of anonymizing transactions, the answer is no. That's not a sort of a primary use case that we're trying to solve with this, because we don't anticipate that many people needing that. And some of the algorithms around this, I think, are a little early still too, although it's really interesting to look at things like Zcash and some of these others and sort of see where that goes. But no, that's not really a primary use case we're looking to solve. You can anonymize data that you put in by using standard encryption. So, there's a couple trade-offs that you need to think about, which we highlight, that if you are going to fully encrypt certain types of data you're going to store, that's fine, but the database can do a little bit less with that data than it otherwise could, specifically around performing database functions around it. So that would certainly be a way to do that. And then I guess the other aspect of anonymity, I guess I'll stop there. So hopefully that addresses the, at least depending on what they were asking about the anonymous question.
Now my mic is on. I think the first thing that most people do when confronted with a decentralized database is to, in the back of their mind, figure out how to centralize it. And and that's fair, right? But I don't think that's a good application. I know that a couple of the people that are going to be here are going to be concerned with security, cybersecurity, and breaches and things of this nature. And you know, when you have an immutable database that's public, there's things you can do. You can hash the data. You can encrypt the data. I've seen some things where they're actually taking a key and encrypting a key and putting that on the blockchain, but it's a key that won't open until a future time in the future. So in order to get to the data before the time that's on the key, you have to break the code that's on the hash for the key, and then break that. So there's a lot of things that are going on there. But when we're talking about the public blockchain, that's one thing. When we're talking about a consensus where we have a community blockchain, that's another thing. We want to keep other players out. We only want to have that blockchain available to our community, and that's it. And we provide some sort of a consensus mechanism, algorithm, be it proof of capacity, proof of work, proof of stake, proof of leadership. There's 4 or 5 different ways of doing consensus coming down the pike, but it's not always appropriate to be looking at our data from a security standpoint on who can touch our data when it's public data, right?
Yeah, that's right. And I would only add that you control when you set up a database, you initially, whoever turned it on, sets up the rules that govern exactly who and under what conditions data can be updated. And again, you can get really rich with this. You can actually write custom programs that are determining if someone can update this entity in this particular attribute. So that is initially set up, and then you can establish, either you can hold on to the keys and change it whenever you want, in which case it's visible to everybody what's changed. Or you can set it up in a way where you no longer have permission to change the rules, but you set up essentially a voting mechanism that elects people who then determine whether or not they're going to approve a rule change or not to what can be updated, how, or schema changes, or whatever the case may be. But in that regard, it is not like this public database that anyone can do things with. It runs by a set of rules, and those rules, even if they're functional code, actually happen to sit as data itself and is stored in the database as data itself. So they actually create their own blocks.
So member proposed schema changes that have a member consensus in a community chain.
Yes.
I have no idea what I said, but hey.
You're on our marketing team now.
Interesting stuff. Really interesting stuff. We got 2 more questions here. I don't want to get sidetracked. I think I could talk about for another hour just on that one fact right there. But let's talk about. And it's another privacy issue. How are we approaching privacy in your blockchain? Will applications be able to leverage both public and private databases? I think we more or less answered that. Did we or did we not? Yeah,
I guess the only quick thing I would add is that your applications don't talk directly to the blockchain transactor. So that's an important thing from an architecture standpoint. They talk to a query engine. We have a lightweight JavaScript query engine that can run right in your app. You may set up a Java-based query engine, which we also have, that will run as a server, and you can scale those as much as you want. But those query engines, because your app is actually talking to them, those query engines may be aggregating data across multiple databases together and displaying them to your application as though they are a single database. So the idea here is that you can really grab data from across different consensus modes, different databases, have them merged at this query level, and your applications can remain incredibly simple. They don't have to connect to this database and that database and that database for different data. They can connect to one database, and the query engine has abstracted all of that from them.
Good. One more question, and then we're going to get on with closing this thing out, I think. So the concept of privacy volume control, yeah, I like that, sounds viable to control levels of public access. And this is, again, coming from Ed. So Flip, you want to answer this one? So the concept of privacy volume control sounds viable to control levels of public access. I guess that's more of a comment than...
Yeah, I don't know how to actually answer that question for that reason, but I think that permissioning is a very rich part of who can and who can't. Maybe it'd be worthwhile to go through a little bit of that. It resides inside as a data element of the database, and therefore, if you hand a Fluree database to somebody, they really can't decipher it, like they can if you hand them an entire Oracle database. You can hack through that all you want.
Yeah, and there's one version, and that's the version. And unless you've got an Oracle database with some really, really cool version controlling, it's hard to lens the data as it was 10 years ago or 5 years ago or what have you, which is an interesting concept as far as databases are concerned. It is getting to the top of the hour. I wanted to thank you guys for coming on board. I want to say one thing that we're going to give you a free community version of Fluree for being here. And if you'll go to fluree.com and scroll down, you get a free 50 meg blockchain storage, 100 megabits with query, 250,000 transactions or database function calls, 100,000 requests of 1 kilobit, 100,000 function calls. So there's a database that you can go to Fluree, and Fluree is FLUR.EE, and scroll down, and there's a free community version that you can get just by coming to Blockchain Weekly and sticking with us for the hour. We're going to give that to you. Of course, if you just go to Fluree.com, you get the same thing, but we want to promote. We want to promote Blockchain Weekly. We want to thank you guys for coming out. We really appreciate you. It's been kind of a top-heavy conversation today. I'm definitely going to have to go away and have lunch now and just give this all some thought. There's some interesting things on a couple of projects that I'm working on right now. And Brian, I'm definitely going to be reaching out to you in the next couple of days and pitching you on a couple of applications that this might be interesting. Going to get you together with my developer. So I want to say thanks to Shindig. This is a really interesting environment. I know there was 24, 25 people at the top of it. There's been a couple of them that dropped off at the top of the hour, probably lunch hour type engagements, but you guys were able to raise your hand and ask questions. I hope we got all of your questions answered. You guys were able, as part of the audience, to get together and talk to one another, can actually connect with one another inside the audience, which is an interesting thing as far as Shindig. And Shindig is SHINDIG.com. If you're interested in this type of environment and doing these types of events, please give them a call. And Mike is my guy. Just tell him you want to talk to Mike, the guy that's doing blockchain consultants. He'll be able to hook you up. I'm Mike Noel. I'm the CEO for Blockchain Consultants. We're doing a lot of really what we find that we're doing is we're doing rationalizing workflows. So we're going in and looking at business process and business development that's been going on since the dawn of mankind and done a certain way, and databases that are built in certain kinds of ways. And well, a lot of the things that we do revolve around the way the databases are written as opposed to the way that we really want the workflows to function. And what we do is we go in, we start rationalizing workflows and implementing a blockchain solution. And it's an interesting business to be in, and it's an interesting time to be alive, and a lot of things going on in blockchain. We have one more questions. And that is, anyone can continue a conversation with us at inflow.fluree.ee. Happy to chat further with any further questions. So we've got someone from Fluree that is ready to chat with you and answer other questions. And again, it's flur.ee. Flip, I really appreciate your time and your work here. It's been fun. It's been engaging for me. It's been interesting for me. I'll be honest, I'm going to have a bit of a headache trying to get my arms around some of the things that you guys have said, but I'll try and get that done. And we really appreciate everyone's interest and everyone's input. Brian, we really appreciate you coming to the board here. Kevin is in the background. Kevin, we appreciate you connecting with me on LinkedIn and helping to put this thing together. Appreciate everyone's time. Go ahead if you have questions. Any questions? We're gonna sign off now. No questions. Thanks a lot, guys. Welcome to Blockchain Weekly. Thanks for coming, and be sure to tune in again next week. Same bat channel, same bat time. Thanks, guys.